everybody. Thank you for joining me today with this talk. I am very excited to be here talking to you guys at GraphQL Conf. GraphQL is something that's been close to my heart recently, and the topic that I'll be talking about is something that I get to work with on a day-to-day basis. I am a developer advocate at Prisma, and there we have our Prisma Schema language, which is just a schema that sort of defines your database's shape. And so I work a lot with schemas. I work a lot with APIs, and I deal with a lot of people who are sort of confused about the different schemas they work with. So that's what we're going to be talking about today. The different schemas that you get to work with, what roles they play in your application and in your infrastructure, and how you can navigate them properly. If you don't know me already, my name's Sabin. Like I said, I'm a developer advocate at Prisma. I started there a couple months ago as my first jump into full-time developer advocacy. But previously, I've spent the last 10 years as a full-stack developer at various companies working with various technologies. So I've been around the block a little bit and have gotten to touch quite a few different things. So it's nice to be able to work in developer advocacy now and do talks like this where I can share some of what I've learned and learn from the rest of you guys. And that brings me to my next point here. I have my Twitter handle up there. If you have any questions or if you have any critiques of the stuff that I talk about, or maybe need some clarification, please absolutely feel free to shoot me a message on Twitter. Just shoot me a message in my DMs. I love to get responses to these talks, and I would be very happy to answer any questions or talk with you. But jumping into more of the meat and bones of this talk, like I said, we're going to be talking about schemas, all the different kinds of schemas you can work with, and why they are a necessary part of your applications. But before we get into the main pieces of it, I want to set up a little bit of context. I want to set up sort of the model of why we even need schemas and how they even came about. And to do that, the first thing that I'm going to mention is a pretty obvious blanket statement that I'm sure everyone here has heard already, but that is that our world runs on data. If you think about maybe your Facebook ads, when you go onto Google and you see recommended lists, or if you're like me and you're too lazy to actually get up and go to a store, if you go on Grubhub or DoorDash and they recommend you certain foods, all of that kind of stuff and many, many more things run on data. Data is what powers our world right now, and there's countless applications for all of this data. And I bring this up because it's important to remember for us as developers that not only do we consume this data, not only do we get to sort of look at this data and understand it, but it is our job to manage this data. And that seems like a heavy load. That's a big weight on your shoulders as a developer. I know when I started working more professionally with bigger companies and big data sets, it was kind of like, I was really like, oh my goodness, this is a big responsibility. How am I supposed to manage all of this data? I just want to make cool web pages. I want to make fun APIs. I didn't sign up for all of this. But if you really think about what your job entails, working on applications, whether you're a front-end developer, a back-end developer, or a database developer, really in any of those cases, at the end of the day, you're dealing with data. Your application is meant to take in some data. It's meant to spit out some data. If you're working maybe not even in an application, if you're working on some tool or maybe a microservice, within those, your whole job is to deal with the data that goes in and out of those. So really, your whole life is revolved around working with data and managing it. And let's think a little bit about what that actually means for you as a developer, though. So as you work with this data, there's something to keep in mind here. In order to manage a set of data, you have to have some sort of knowledge about its structure and purpose. And at face level, this seems like a pretty easy statement. It seems common sense. Yeah, you have to know some about your data before you actually start working in it. But if you really drill down into this, this is actually a pretty big task for us as developers. We have to understand the structure of our data, the different types that are within your data set, and even the relationships between different nodes within your data. So there's these things and a bunch of other things that you have to keep in mind as you're working in your applications. And it can actually become a pretty big task. Data is really hard to visualize if you don't have a proper structure in place. And as developers, we already have to deal with working with technology stacks, keeping up with current trends in technology, making sure everything's safe, and using best practices. So this is just one more big task to pile up on top of all of that. And what it boils down to is that we're essentially in some way acting as subject matter experts, not only in the technologies we're working with, but with the data we're working with as well. And because of this, I'll adjust the last slide that I had. It's our job to manage our data and also to understand it. And I know this probably raises a couple red flags to people listening, because understand is a very loaded word. That could be a deep understanding where you're ingrained into the sort of system of how this data comes about and how it flows through applications. And that's exactly why I think this talk is important to keep in mind, because in some reality, that is the case. We are expected to be able to efficiently navigate this sort of data and work with it. And because of all of this, the thing that I'm going to be focusing on in this talk is the fact that data is hard to model. If you think about all of the different use cases for your data, how it goes in and out of your application, the way you interact with different pieces of your application and even different parts of your infrastructure, there has to be some sort of model for your data that makes it predictable and easier to read, not only for the application developers, but for a human looking through the code trying to understand it. So we're going to be exploring sort of how to properly model your data and why that is important. But as this slide says, it is a very hard task to do this. So I've put together a non-exhaustive list of just high-level overviews of some of the things that I think make modeling your data very difficult. And then we're going to talk about some solutions to these. So the first one here is that your data flows through disparate areas of your application. And this is one that has bit me in the butt a lot of times. And I'm sure as I'm saying this, a lot of you are probably thinking back to different times where you've worked with data, and as it flows from maybe one microservice to another, or maybe as it flows from a front end to a back end, or vice versa, sort of the shape of your data and the type of those pieces of data get lost in your head or in the code even, and it becomes a difficult task to sort of understand and expect a certain shape of data as it flows through your application. So this makes modeling your data pretty hard, because you have to model it in a way where it produces an expected result every time you move this data from one location to another. The next thing that makes modeling data pretty difficult is the fact that your application can change, and that will cause your data to change as well. The shape of your data, maybe you've added or removed fields, maybe you've changed fields, maybe as your application grows, a new relationship is made between different nodes in your data. And these are all signs of healthy growth of an application. This is actually a good thing. But as far as the data goes, this complexity also has some negative effects. It makes it harder to model your data, because now you have to also keep in mind what might happen if you change your data set. Will that tank your entire application? Will your data model be able to handle these kind of changes? So keeping that in mind is another thing that makes your data hard to model. And then the final thing is that your data may not have been modeled by you. And this one to me hits home very hard. I know there's been multiple times where I've been working at a company, or maybe I just started working at a company and I'm jumping into a new application that a different team was building before me. And I'm sure a lot of you can relate. It's very difficult to do this, because you jump into a code base, you're trying to learn your code, you're trying to learn how everything's put together. And then at the same time, you also have to learn where your data is, how it's stored, what shape it's in, what types to expect. And all of this stuff comes together to make a very difficult problem of modeling your data in a way where you can actually effectively work in it in an efficient way. And this has all led developers to come to the conclusion that they need a better solution. They need to find a way to put their data in a format where a human could just scan through it and get a high-level overview of what data you're expected to have and how it might be used. And also, on the code side, you should be able to look at the schema and know what a specific piece of your application is actually using from your entire data set. And because of all of this, this is where we came up with the idea of schemas, which provide you a clear and concise way to represent your data. And so schemas have actually done a lot of good. Schemas are very great and they help developers. So we're going to talk through a couple of the things that make them good, and then we're going to talk about some of the downfalls as well. So very first, let's just sort of define what a schema even is. That way we have this context set up for us. And I'm going to paraphrase a definition here. The definition of a schema is basically just an organization or a structure for a database or a set of data. And this is in a written format somewhere in a file or something similar to that, where you're just defining a set of data. You're letting the reader of this schema know what data is there, what data is available, which structure it follows, and the different types and relations within that data set. So the result of this is a human readable representation of your data, its types, and the relations. And this human readable keyword here, that's what's really important. It should be something that you can look at and sort of understand what's going on, what data is available. And these can follow many different formats. It really depends on how you implement this. Most often you'll see a custom schema language like the Prisma Schema language that we offer at Prisma. There's also JSON, XML. I didn't add it here, but there's DDL, which is database description language, typically written in SQL. So there's a bunch of different formats. It really just depends on the context of your application and the technologies you're working with. So why do we even need these schemas? We've already talked about how they sort of help you organize and define your data, but what really is the benefit of these? And I've put this into 3 different categories. And the first one you see here is understand, because schemas help you to more easily read your data. They help you to more easily read your data in 2 contexts, both scanning through to sort of understand what data is even available, and then also within your code. Schemas help you to actually read your data through your code and understand what data is available at any given part of your code base. The next piece is that it makes relations clear, which is another super important one. Keeping track of relations is always difficult, and typically a schema should define these and make it obvious what relations are there. And then finally, it helps clarify the domain. And by this, I mean it helps clarify the data available to you within a specific isolated section of your application. If we're talking about maybe an API as a whole, there's going to be a couple of different sections there. There's going to be your database. There's going to be your actual API code. There's going to be the exposed API endpoints. And all of these are going to have different definitions of what your data should look like. So these schemas help you define and clarify each domain, I'll call them. The next piece is integrate. And what I mean by integrate is that it allows for simpler communication between systems and defining rules for the data. So as maybe microservices are communicating, these schemas can be used to generate types and expectations and sets of rules for what the data should look like as it crosses over the network. And then finally, there is transparency. And what I mean by this, and this is more of a higher level sort of benefit here, is that it allows non-technical people to better understand your data and gives insight to maybe new developers on your team or junior level developers working in your products. And this is a really important one here because there's a lot of cases where maybe a product manager or somebody needs some insights into the data that's being stored, being collected, flowing in and out of your application. That way they can better produce ideas for new products or new directions and new features for the product. And what schemas allow you to do is provide this more human readable set of instructions for how to read your data. That way, even a non-technical person with maybe some knowledge about what to expect can actually read the schema and understand what sort of data is there. So that is why we need these. But if you actually start to think about implementing schemas, there's still a problem. So we have a bunch of different disparate pieces of our application using data. And so we've implemented schemas to sort of organize this data into a more readable format. But now what happens when your application starts getting more complicated? Maybe there's more areas of it. Maybe you switch to a microservice where you have a bunch of different applications dealing with different sorts of data. And because of this, what we see is that there is still a potential problem, even when you're using schemas. And that is the fact that there are schemas everywhere. And this one, I smile because this one also hits home for me. I remember when I was first learning GraphQL and first starting to work really deep in the backend side of things, I was always confused about what schemas roles were and which individual schemas were supposed to do what. There's so many different schemas that you can work with out there. And actually in this talk, we're going to be looking at sort of an example that's going to be something like this, where we're going to have a database, we're going to have some code, and then we're going to have a GraphQL API. And what we're going to do is sort of look through the individual schemas for each of these and define their roles and their set of instructions for our application. But thinking back to the problem of having multiple schemas, why is that even an issue? You would think that more organization would be better. But with too many schemas, a few issues can arise. And the biggest one here that I've put first is that there are multiple perceived sources of truth. So if you've worked in an application with multiple schemas, and by that I mean maybe your database schema, maybe you're working with Prisma and you have a Prisma schema, and then your GraphQL schema, these all act and are intended to act as sources of truth. But when you're actually working with these and you're actually developing against these, if you have multiple schemas, it can be difficult to determine what schemas should contain what and what the role of each of these is. And that's because each schema can describe data differently. Different areas of your application, different microservices that you're working with might only care about small subsets of your data rather than the full the full data storage in general. It may only care about, for example, if you were looking at an auth microservice, it may only care about user data, where if you had maybe an invoices service, that would care about a wider set of data regarding invoices. So in those cases, you might have schemas only describing small subsets instead of the entire set of data. So that can get confusing because then that sort of disambiguates the data and makes it less obvious what data is available to you as a whole. And then finally, each schema has a different role. And this is the one that gets a lot of new users of GraphQL a lot, even a lot of new users of different technologies like TRPC and things like that, is that these schemas each have a different role. They play different roles, and while they might look similar, they aren't supposed to be the same. And that's very confusing for a lot of new users. And that's what we're going to talk about next. But before we do that, so let's just keep in mind this important point here, that each individual schema in your infrastructure defines your data in the context of its own domain. And this sentence may be confusing. All it's really saying is that each section of your application, be it the database, the API code, maybe your exposed GraphQL endpoints, maybe individual microservices, each of these are their own domain. And each of these will likely have schemas that define that data in the context of its own domain. And sort of navigating those, organizing those, and orchestrating those is what our job is here. So we're going to look at an example, sort of imaginary stack, and we're just going to assume we're using Postgres, Prisma, and GraphQL. And of course, Postgres will be our database layer. Prisma will handle the database interactions, and then GraphQL will be the exposed GraphQL API. And looking at the first piece, looking at the database schema, this is what I call the data storage piece. All this cares about is defining all of the data that's available in our data source or data sources, maybe multiple. And usually this will look something like this in a relational database. You'll have a set of tables, you'll have a set of collections if you're in a NoSQL database, and these will define the different columns that are available within those tables, the different data types, different relations, and maybe some indexes. So you'll know how to query your data and set up some rules around how you can access your data and how it relates to each other. That's what the database layer does, and it'll do this for all of the data that's available to any of your applications. This is more of the centralized store of your data. And this is normally written in a database-specific format. And for example, with Postgres, this will be written in SQL, which is described as the data description language, or DDL. And as you can see here, it's not very intuitive to read. Sure, if you know SQL, you could look at this and say, okay, I know what a lot of these are doing. I know some of the relationships. But if you're someone who's maybe less experienced in SQL or non-technical, this can be a little bit daunting to look at. And that's where the next piece comes in. That's where Prisma Schema comes in. So this is what I like to define as the source of truth in a stack like this. And that's because what Prisma does is it sort of unifies your code and your database together and defines it in one much easier to read location. So let's look at an example of that. Right here, what we're doing is we're defining our data source. So you can see the data source block there has a provider of Postgres and a URL equal to some variable that contains a connection string. Above that, you have the generator, which defines how Prisma should generate the database client, so you can actually query and interact with your database. And then below that, I've shown one model here, but this will likely be a long set of models where you actually define your database schema through your Prisma schema. And the cool thing about this is that Prisma schema is much more geared towards people who've maybe worked with GraphQL in the past. The format here is a lot easier to read, and it's a lot clearer what's actually going on. So even as a non-technical person, if you look at the user model here, you can see, sure, there's an ID column. It's an integer. The default value is an auto-incrementing number, and so on and so forth. As this goes down, sort of the relationships and the types of your data and the whole structure of it in general is made a whole lot clearer than looking at plain DDL format. So this is one of the benefits that Prisma gives you. And the reason this acts as the source of truth is because you can then take this, run a migration, and this schema will be applied to your database schema. So it keeps those sort of in sync, glues them together, and it allows you to much more clearly represent that schema. The next thing that it does is it actually glues your database sort of schema defined through your Prisma schema to your application's code. So you now have this one schema sort of managing the expectations of your data shape for both your database and for your application code. So here you can actually query your database. You can, in a type-safe way, run different operations against your database. And it's all through this one schema that's sort of acting as the source of truth. And then, of course, the other benefit of this is that this schema is then source controlled. So within your GitHub repository, you can actually see how your data has changed. And that becomes helpful if you need to maybe roll something back, or if you need to look at what may have caused a problem. You now have this sort of source control of your database schema and the expectations for your application's code. And then going on from here, this is written in, like I said before, Prisma Schema language. It's a lot simpler to read than the DDL, and it allows you to generate the Prisma client. So those are the important points of using Prisma. And then that takes us on to the last piece, which is the actual GraphQL schema. And I call this the API piece. And before we actually get into the role of this, I want to quickly mention that there are different ways to build up your GraphQL schema. There's SDL first, where you would manually write your GraphQL schema using a .graphql or .gql file. And this is where you would actually use the GraphQL syntax, the GraphQL language syntax, to actually write out your different types, write out the expectations for how to query and mutate your data, and you would do that in a manual way. But then there's also this, this concept of doing code first, where you use a library like Pathos or Nexus, and using these, you can actually programmatically generate your GraphQL schema using a familiar language. In this case, we'd be using JavaScript. And what this will actually do is run a couple of functions, however you define them. And the end result would be that it spits out a GraphQL schema that you can then apply to your GraphQL server. And in many cases, this is what I recommend to a lot of people to do, because, and we'll get into this a little bit more in the next couple of slides, but this allows you to more easily sort of meld your entire application into one nice and safe lump of application code that has good expectations of how your data should look. But moving on to more of the role of the GraphQL schema, your schema is going to look something like this. You're going to define a bunch of types. Here we have a type query where it defines all of the different queries that we can run against our API. We can get a user, get an invoice, get different tags for an invoice if they have maybe labels or tags. So we're defining what you can send to those queries and what you expect to get back. And then below, you can define what the shape of your data should be. So this is taking care of one of those points where you're defining clearly and concisely what your data should look like and how you can interact with it. But it also allows you to define, like I said, the interactions with the data. So not just the shape of the data, but the rules on how you can actually touch this data and interact with it. And this is where something like Pathos or Nexus comes in handy, where you can clearly sort of build up your GraphQL schema in a way that is safe with the rest of your schemas. So for example, if we are taking a look at this imaginary scenario where we have Postgres and Prisma, each of those have their own schemas, but they're kind of melded together because Prisma is acting as the source of truth. And another thing Prisma does, like I'd mentioned, is generates a type-safe database client, so you can safely interact with your database, and it prevents you from making mistakes. What you then do is you can use that generated client to use a code-first GraphQL schema builder, and then you can use that type-safe client to build up your GraphQL schema. And what that's going to do is allow you to sort of all across the board get that nice type safety as well as data expectation safety across your application. And the goal of this and the role of your GraphQL schema in general is to present a GraphQL schema that someone can consume and expect what they should expect back. So the role of the GraphQL schema is not to redescribe your database as a whole. It's not to redescribe what's available to your code, but what it is it describes the data that you actually want to expose to your users. So this is important to keep in mind because this is where a lot of people get confused with GraphQL. I know I did when I started with GraphQL. I always thought it was redundant. Why would you redefine your database schema in your GraphQL schema just to expose it through an API? And the reason for this is that your GraphQL schema does not match what your database schema has. And in fact, it, in most cases, shouldn't match. There may be security flaws there. Your GraphQL shouldn't expose raw passwords. It shouldn't expose certain bits of data that the user doesn't really care about. The cool thing with your GraphQL schema is that you can actually pick and choose what you want exposed to your users through your API. You can pick and choose which queries are available to your user and how they can use them. And that's the whole role of the GraphQL schema. It's to sort of narrow down your data set into one set of data and different sets of collections of data that your user can access through your API. So it's different from the database in that it doesn't describe your entire set of data. It's different from your Prisma schema in that it doesn't care about how you connect to the database, it doesn't care about your data model, it doesn't care about the application code's types. It's separate from both of those in that it only cares about what the user of your API or your application can access. So that's how it differentiates there. But if you are familiar with working with a stack like this, you may already be running through your head, what about the gaps? And you may wonder also what even the gaps are. So let's look at this. If you look at the stack that I just laid out for you, what we have is our database layer, which would be the Postgres layer, our API layer, which is GraphQL, and there we'll have the Prisma schema and the GraphQL schema, both working in that layer. And then we have the client, which is whoever is actually accessing that API through the GraphQL schema. And the gaps between those are what describe the data as it travels from one piece to the other. So as data travels from your database to your API, or from your API to the consumer of the API, how can you be positive that the data's shape is what you expect? And so that's where Prisma comes in here. Like I mentioned before, it sort of glues the database and the API together. Because it is acting as a source of truth and generating types for your application code, it ensures that you have that nice safety between your database and your API. But the more important one to look at here is between your API and client. This is often a larger gap. It's a lot harder for people to visualize how to actually manage this. And the way you do is you use a tool like GraphQL Code Generator. So what it does is it'll actually read your GraphQL schema and it can generate types for your client or whoever's accessing this data based on your GraphQL schema. And the reason I even mentioned this, although it's not directly related to schemas, the GraphQL Code Generator tool, is that what the purpose of these schemas is that they actually make things like this possible. So as we develop different applications and disparate areas of your application, and maybe tools that weren't even built by you are accessing your application, you can use these schemas as starting points for tools like GraphQL Code Generator to read them in a clearly and easy to read way. That way they can set up the expectations in their own applications for how to interact with these. So that's one of the main benefits of how schemas, even working with multiple schemas in the same project, allow you to more easily manage that disparate data and organize all of your data as a collection as a whole. So that's the role of the three different schemas that we're talking about here. And I'll quickly just recap it a little bit. So we've got our database schema, which defines the data that's stored in your database. It defines the entire data set as a whole. It doesn't really care about specific domains of your data set. It just describes all the data that you have. Then you have your Prisma schema, which sort of redefines your data model, but it doesn't really redefine it. That's supposed to be where you actually define your data model, and that model gets applied to your database schema. So it's the source of truth. It manages both areas, the safety in your database schema and the type safety in your application's code, and it sort of melds those together. And then finally, you have your GraphQL schema, whose role is to actually define what a user can access from your database. It shouldn't match your database because it should pick and choose what you as a developer or you as a company want your users to be able to access and how they should be able to access it. So that's the role of the three schemas. And I really do hope that cleared up some of the confusion, because I know when I started, I know a lot of the people that I work with as I get people into working with GraphQL and Prisma, they have a lot of confusions around all of these different schemas and how they should interact with each other. So thank you so much for joining me on this talk. I really do hope it helped a lot. And like I said on the first slide of this, if you have any questions about it, please feel free to shoot me a DM on Twitter. There's also going to be a section after this talk where you can actually ask questions, and we'll be able to get those answered for you. So thank you so much for watching, and have a great one.